So we're going to be working on our projectile motion test review here. Test guys tomorrow. Now, as we're going through this, please follow along, and we're going to walk through how to do most of these problems, and then we're going to go through some of the multiple choice aspects together. So again, you need to know what everybody stands for. Vx is horizontal velocity, delta x is the horizontal distance or displacement, and then t is your time. Now, time is the only variable, guys, that is in both sets of vertical and in the horizontal.
Dan Savito, please call the main office.
So with that, if you can get time, that guy is then you can insert it into either set, in the vertical or in the horizontal. So again, to work the triangle, cover the letter up that you're looking for, and then it's going to wind up telling you what to do. Cover up delta x, it's Vx times times. You're looking for Vx, cover that up, it's delta x divided by time. Okay. And we're using, remember, negative 10 meters per second squared for our acceleration for this course. Just makes the numbers easier, but what is the actual value? The negative 9.8 or negative 9.81, depending upon what source you're looking at. Okay, number one, a ball rolls off a desk at a speed of 13 meters per second, and it lands 0.04 seconds later. How far from the base of the desk does it land? How far from the base? Well, that is dx, or I'm sorry, delta x. And then how high is the desk? Height is basically going to be our vertical displacement slash height, which is dy. Okay, so with all those things being said, delta x, I'm going to solve for that guy first. So I'm just going to go next to Vx, I'm going to space it out a little bit. And then I'm going to scoot up here, and I'm going to just copy this equation. So you highlight this, Control C, then scoot down, Control V, and then underneath it, we're just going to do our math for it. It's going to be 13 times 0.4. All right, let's type that out. 13 times 0.4 comes out to be 5.2. And that's going to be meters. So that is going to be one of our answers. That is our answer for delta x. And then to solve for dy, you have our equation here, which is very simple because if you're given time, it's just time squared times negative 10 divided by 2. Now that's vertical displacement. But if they're asking you for height, you still use the same equation, but then you just drop the negative because you just can't have a negative height. So highlight this piece, that John, and then go underneath here. I'm going to paste it. And then I'm going to go underneath that guy here to do the math. Yeah, we're going to do our test on quizzes. Let me zoom in just a tiny bit more here. Okay, so we have 1/2 g is negative 10 times t squared, and it's important to only square time. So it's 0.4 squared. Do you guys remember how to do the square? Control period. Type your 2 and then hit control period again, and it comes down. Okay, so 0.4 squared should be 0.16 times negative 10 divided by 2 will come out to be a negative 0.8. That's basically telling us how far it fell, right? Because d sub y or delta y sometimes as shown dy vertical displacement, which means it's below where it started.
How do you do that?
Squared?
Yeah.
You control period and then type your number, whatever you need, and then hit control period again to go back to normal font. No, to get the subscript thingy, it's control comma. Control comma gets like the subscript looking thing. So that negative 0.8, that's how far below it is, right? Because it's giving us a displacement. But they're asking, if they're asking height specifically, and you don't see negative as an answer, so height is just going to equal, you just drop the negative, 0.8 meters. Same magnitude, but the negative sign, because this equation for displacement, is the reason why. Highlight your answer, and boom. Okay, so moving on then to the next one. But okay, so number 2. That's annoying that it's so spaced out here. Bang. I'm just doing it so you can see it better. All right, so we got a slingshot. The slingshot is used to launch a stone horizontally from the top of a 200-meter cliff. Now, if you guys didn't have this information here, that's a height, and that would be our dy, that 200. Now, the stone lands 365 meters away. How far away, how far from the base, that would be our delta x. And then they want to know what is the speed at which this stone is launched. So they want Vx. Okay. Well, to get Vx, what is my equation? If I scroll up, Vx is this. So I'm going to copy this. Vx is delta x divided by t. So if I go to that and I copy it, and then I go down here. All right, I have delta x. What don't I have? I don't have time. So again, if we go back here to our equations, t is the one thing that can be used in both horizontal and vertical, and you're usually going to be able to figure it out from one set. So if you have both delta x and Vx, you can solve for time. If you have the height, which we do, you can then use this equation here. 2 times dy divided by 10, and then square root our number. So that's what we're going to do first. I'm going to scroll over here. I'm going to paste that. And I'm going to hit control paste again. And then I'm just going to go in and edit our dy. So instead of it being, what is the dy? 200. So I'm going to just put parentheses here, 200. So 2 times 200, 400 divided by 10 is 40. Now I have to take the square root of that. So I'm just showing you guys. I'm just showing you guys like the full step-by-steps that I'm doing. You don't, I mean, you won't necessarily need this part here. And then I square root 40. And that comes out to be 6.3245, blah, 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 and change. So I'm going to cut it to 2 decimals here. So you need this first in order to get the final answer of Vx. And now that once you have both of them, delta x, which was given in the original, so it'd be 3, oh Jesus, what'd I do? Oh, hit the wrong button, that was lie. 365 divided by time of 6.32. My first period, I accidentally multiplied it, and someone like caught it a little later because we were talking about like that's wow, it seems pretty. It was like a very high number. It was like right, what was that? It was like 2,300 and change meters per second, and if you multiply that by almost 2.24, that'd be like 5,164 miles per hour, which would have been insane for a slingshot. This is still a relatively high number. I think it comes out to be like 57 ish. So 365 divided by 6.32. And this answer comes out to be 57.75. And change, but we're going to just cut those off. And the unit for velocity is meters per second. Roughly 129 miles per hour. Which, I mean, if it's a wickedly crazy slingshot, definitely more plausible than the other number that we had. All right, bam. So we need to solve for time first in order to then answer this question completely. Now in number 3, it's done almost the exact same way, but we're looking for delta x. Oh, you what? So in order to get our horizontal displacement, here's the equation that we need. Delta x is Vx times time. So this is for number 3. So I need this equation in order to solve. I have one of the two things that I need. I have this 1,300. What I don't have, again, is time. So given height, though, I can solve for that to get time. Oops, undo. Highlight this, Control C. Okay, so then I'm just going to go into, once I Control V this, paste it, right, I get my numbers here. So it's 8,100 times 2 divided by 10, which would be the square root of 1,620. And so T will equal the square root 1,620. And that comes out to be 40.249. So we'll round it to 2 decimals, 40.25 seconds. So again, I needed to find time in this this aspect here first, and then I can use it to solve my final actual piece here, this Vx. So it would be 1,300 times 40.25. And that in the calculator kicks out an answer of 52,325. And that will be meters. Okay. All right. So number 4 is done just like number 2. Number 4 is going to be done just like number 2. Number 5 is going to be done just like we didn't quite do number 5. One like this. So, all right, we're going to do 5 real quick. They want dy. To solve for that, my equation is this dude here. Oh, wait, no, we did do this. We did one just like this. Haha. So we did Vx, solve for Vx. So number 4 is like number 2. Number 5 is like number 1. Just like number 1. And number 6 is done just like number 1 as well. This one, you get time. Use these two numbers here to get time. And then solve for dy. So we'll look at the setup on that one real quick. So go down to here for dy. I'm going to paste this. Let's make it a little bit smaller. And to solve for time, all right, because in this equation, dy is equal to 1/2 gt squared. I need t. G is a constant of -10. So that's good. We already have that. So yeah, you got to solve for time first. And you are given both of those numbers. So it'd be 93 divided by 30. And so you should get a time of 31, I believe. Or no, 3.1 there. 3.1 seconds. So you needed that. And then you can solve here for dy. 1/2 times -10 times, you go to square time only. So 3.1 squared. Put that guy in parentheses. And that's going to equal, let's do that, 3.1 squared times 10 divided by 2. This comes out to give us a negative 48.05. What the heck just happened? Negative 48.05. That's the displacement. They wanted to know how high up the ramp was.
Wait, how do you do that? The y, the little y.
I just copy and pasted that equation from up top. So we just drop the negative off here. And that, guys, would be our final. So you asked, how do I get this, right?
Yeah.
All I did was I went up here and I copied that equation. That was all. Should be 48.05 meters as our height. So 6 and 4, you guys have examples problems just like them to solve. So you guys definitely should be able to complete those final 2 problems on your own. Now, we're going to move then to these multiple choice settings. So for number 7, it asks, how is the initial horizontal velocity right after it starts moving compare to the final horizontal velocity just before hitting the ground? Again, we're neglecting any and all air resistance. So with that, or because of that, if there is no air resistance, there's nothing behind it, all right, pushing it, making it accelerate. And if there's no air resistance, there's nothing in front of it causing it to slow down. Because of that, The horizontal velocity remains constant, so they are equal. They are equal. Okay, well, what about the next one, number 8? How does the initial vertical velocity, so right after this thing starts moving, compare to the final vertical velocity just before hitting the ground? Guys, someone is got to mute their mics here. So how does the initial vertical velocity, right after it starts moving, compared to the final vertical velocity? So if I were to drop something, initially it's what? If I were to drop something, what's its initial speed going down? It would be 0. Gravity acts in what direction? Downward. So gravity is an acceleration, so it would cause us to be hitting the ground, right? The final vertical velocity would be greater. Now, if you were throwing it straight up, that's not said here. What they said is if, right, this is basically assuming that they're dropping it here, then yes, the final velocity would be greater. But I think there's a question on here that asks, if you throw something up straight up vertically and it leaves your hand at 30 meters per second, right, with positive velocity going upward, and you held your hand just out right as wherever you threw it at, it would land on your hand with the same speed, just with a negative sign for velocity because it'd be on the way down. But if this thing is dropped, it starts off slow and it gets faster as it falls. So acceleration, that involves a change in speed. In what direction does a projectile accelerate? Remember, there's no air resistance, so there's nothing slowing it down in the x direction. If there's no forces in the x direction, the only thing that's acting is gravity, and gravity is vertically only. The only thing affecting a projectile is gravity. Ooh, here's a good one. Doubling the launch speed of a ball off a table causes the time to blank and the x displacement to blank. So remember from last week, we had a couple of different, that we went through a few different simulations. 2 objects, one was basically dropped or rolled off at like 1 meters per second, and the other at 60. They took the same amount of time to hit the ground, right? So that means this one right here, doesn't matter if one is dropped or one is rolled, all right? If they both go from the same height at the same time, they're going to hit the ground at the same time. So the time is not going to change. So that means we're basically looking at either C or F. But the displacement, how far it's going to go, what do we think that? Well, if you double the launch speed, yeah, it should go double the distance. It shouldn't go less than that. So C would be the answer here. C would be the answer here. Number 11, the acceleration due to gravity acts downward. Downward. Number 12, a bullet is fired at an angle of 45 degrees, neglecting air resistance. What is the direction of acceleration during the flight of the path?